Crowd here. Good to see you guys. So we're talking about keyers today. So first question is anybody here ever used a keyer? Any CW ops out there? Okay, we have Rich. That's good. All right.
I'm learning.
Okay, good, good. So this is some traditional ham radio here. It's for sending Morse code. So what is an electronic keyer? It is a device for automated sending Morse code. Traditionally, you have a hand key, the little familiar telegrapher's key, or maybe a semi-automatic key known as a bug. Someday I'll do a presentation on Morse keys. That might be kind of fun. So it generates the dits and das. That's what we call them, not dots and dashes. We call them dits and das at the touch of a paddle, as it's called. There's a picture of a paddle there. It has two contact closures, left and right, that make dits and das. You plug that in your keyer, and the output of the keyer is basically a contact closure. And when it's key down, you generate a carrier. That's how we generate Morse code. And a modern keyer probably also has message memories like this. The one in the picture has some buttons on top, and you can pre-record messages, like it can send your call sign or whatever you want. This really is the fastest, most accurate way to send Morse code, manually at least. I mean, a computer can generate Morse code too, but we really enjoy sending manually. It's a lot of fun. So a little history. So these go back a ways. As early as 1950, there's a fellow in Denmark who came up with a very simple design using tubes. But the one that really made a splash, 1955, was this guy W9TO. And so he used a few vacuum tubes, and it truly is a digital keyer. And without getting into the circuit and stuff, it actually has a keyed oscillator and a divide by two circuit and stuff like that. So really it was digital logic. And those are marketed by a number of companies. Like there's a good old Hallicrafters, very wonderful old American company, and so it's commonly known as the TO keyer. So that was really a pioneering device when that came out. There were no paddles at the time. It's kind of awkward, like, well, what do you hook up to it? There's no paddle. So that had to be invented at the same time. But by the 70s, keyers were everywhere. Modern electronics made it easier. We got away from tubes and stuff. Like there's an old one from Heathkit in 1965. The one in the middle, I actually owned that one, that particular little funny model. And there they had the paddle built into the keyer. And to this day, there's still some that are built that way. Then a little later, like the late 70s, they started putting memories in it. There's a picture of one from Autek that had some memory buttons. You sort of like hit the record button, start sending, stop the recording, and it remembers what you sent. But the ones with the integrated paddles, they were crap. They were really bad. Crappy contacts. They felt lousy. You could use them, and it's like if you didn't know any better, you'd think they're okay. It's like buying a really bad guitar or something like that. You don't know what you're missing. So. But these things are still around. You can find them on the used market and stuff. They're pretty wild. So here's the basic logic of what a keyer circuit would be. Basically, the paddle, you close a contact, and it detects that the contact is closed. You don't have to hold it closed for the duration of the dit or da. You just touch it, and it says, okay, send a dit, or touch it and send a da. And when that does it, there's a synchronous oscillator that generates the pulses, where one pulse is a dit. So if you hold down the paddle on the dit side, it'll generate repeated dits, and similar for dashes. And for a dash is equivalent to 3 dits. So you have to use a little logic trick here. You divide by 2 and OR it with the original signal. It turns out that will generate the little pattern that's a dash. And you put those together, and that will key your radio. And classically, these are just built from digital ICs, good old TTL or whatever it may be. So this is just a very simplified little diagram, what's inside. So the later models do what we call iambic keying. Not you've heard of iambic pentameter, in poetry and stuff. But so what this does is it has some additional memory, or a state machine, it's a little more sophisticated logic. And this allows what we call squeeze keying. If you actuate both paddles, it will alternate dit and da. So for instance, that's the letter C there, dot it. And so that takes one squeeze. You have to time it. You have to start on the right right side, you might say. But that can somewhat increase your efficiency and your smoothness. And there's actually several iambic modes. I'm not going to go into those. They kind of differ on some subtleties of how the timing works inside the keyer. Iambic B is probably the most common, and that's certainly what I use. But there's other modes that different operators have different preferences. So here's some modern keyer chips. These have been around a long time. On the left is one, this fellow, this little ham by the name of Curtis, back around 1980. He actually paid the money to have a full custom CMOS chip developed. I mean, that would have cost like hundreds of thousands. The guy had to be filthy rich or something, because I don't think he could make that much money back in the ham market, but that's what he did. Nowadays, actually, it's made from a little PIC processor, and you can buy it from MFJ. And I'll actually show you here I made based on that chip. So it's just a little dip IC and a few other, his little power supply and some switching stuff to drive the radio. But that has all the features you'd ever want in a modern keyer, memory and things like that. Then people started using microcontrollers, and here's when some open source software runs on a little Atmel microcontroller. And you can buy these pre-programmed little 8-pin dip and add a few other things to help it along. And it's like instant keyer. You can buy these little boards and stuff. I think you can buy them at eBay and stuff. This is a very popular one from K1EL. It's called a WinKeyer. This one's very sophisticated. It has a USB interface, highly standardized interface everyone uses in all the logging programs. Like, for instance, if you do contesting and stuff, you want to send messages automatically. And the WinKeyer is really pretty much the top choice, and everyone emulates it now. Other people have done it like an Arduino. I mean, it's just a program in a sense. You sense when the paddle is touched, and then you generate the appropriate pattern. It's not a terribly difficult program to write. So people have done that. And so if you have a little Arduino or something like that, you can get some open source software like this guy, K3NG. He offers it. But another thing is that all modern radios, all modern HF radios at least, have a keyer built in. So it has a jack in the back, plug your paddle into it, and away you go. If your radio is off the air, put it in a test mode. You can even use it for code practice. So a keyer with a modern radio isn't even necessary a lot of times. So here's the commercial keyer that I use. This is a WinKeyer, a couple pictures of it, controlled by USB. And you basically configure the whole thing through a little app that runs on Mac, Windows, whatever you want. Actually, it's kind of neat. If you hit the red button on the thing, it's a programming button, and you can send it commands with the paddle in Morse code. Like you can, tell it to, change modes and stuff like that. Pretty wild. They sell a mini version of it. It's a teeny little thing. It's about 1.5 inches by 1 inch and about half price. And you can even buy the ICs. And there's some commercial radios like a Flex. If you buy a Flex with what's called a Maestro control for the thing, it actually has one of these ICs built into it. Because this WinKeyer, it's really, really popular, and the whole world is kind of standardized on their command set. So if you want a computer controlled keyer, this is the one. So here's one I built in 1975. I was a junior in high school. And so this is all TTL built on perf board. I made fabricated the cabinet in the high school metal shop, and this is to match my Drake equipment that I had at the time. And the basic circuit for the keyer and what's called a diode memory, that's a kind of a ROM memory. You solder diodes in to make the pattern. That circuit was done by W9MUC, he was my Elmer very much. She's the one who kind of encouraged me to go into engineering. And I revisited that circuit in the wooden keyer that I was showing the other day. It also has a reprogrammable memory where you hit the start button, whatever you send gets recorded. And that was kind of pioneering at the time, back in the 70s, to have a reprogrammable memory. So that was really neat. And so here I am in 1978, college actually, and that's my Drake gear. And just kind of right above the microphone head, that's that keyer sitting there. So this is my basement in Illinois. And yeah, I was building a lot of stuff back then too. I had a kilowatt amplifier for CW for a while. Must have been just after this picture was done. Very dangerous power supply and all that kind of stuff. But Dad worked at a power company. He said, keep one hand in your pocket and, keep your fingers out of the hot stuff and you'll be okay. So somehow I survived. So here's another keyer I made. This one is based on that Curtis keyer chip. And again, you kind of see the little prototyping board there. So I made an odd enclosure. It's kind of sculpted there out of wood. It has a hollowed out cavity in it where this little circuit board slides up inside. So there's a brass base plate with some feet on it, and that screws to the bottom of the little cabinet. And then the knobs are turned from ebony. Yeah, it was pretty cool. This is a paddle I used to have by a company called Brown Brothers. They're pretty popular back in the 70s and 80s. And then, so this is revisiting, again, the same basic circuit that I used in that big fancy keyer when I was in high school. This time I did it in CMOS. The advantage of CMOS is that it draws very little current. So this is classic, we call low power design. Yeah, CMOS is pretty neat, whether it's 74C or 4000 series CMOS. Essentially, it draws no current. I mean, the power supply current is it can be in the picoamp range. So essentially, this whole circuit can be powered by a battery basically forever if it's just the logic, which gives you a lot of opportunities for like battery powered equipment where you never have to change the battery and you don't need a power switch. So here's making the cabinet for it, a couple pictures. So this is a piece of quarter sawn Honduras mahogany and a piece of hard maple. Glue those together, cut them to just a rough block shape. And then because this thing was all cavities and stuff, I made a drawing. I had to very carefully figure out the geometry. And I have it on a vertical mill here. That was the easiest way to do something like this instead of using classic woodworking techniques. Do it more like a machine shop. And that way I can have these cavities routed out in a precise manner. So that's how I made the thing. And there's what it looks like with all the parts inside. It has a side tone, as we call it. So if you turn that on, you can hear yourself locally. If it's actually keying a radio, the radio itself normally generates a side tone so you can hear your own sending. But this has a little tiny speaker inside, and then there's some holes in the bottom plate. It has a very mellow sound. It's kind of nicely filtered sound. It sounds very pleasant. So you can see the 9-volt battery sits in there, and like I said, it doesn't need an on-off switch because of the low power consumption. And there's the completed thing. And that paddle, that's called a Bigali sculpture. This guy Pietro Bigali in Italy, he makes a lot of kind of exotic keys. He does paddles, he does bugs, straight keys, things like that. And this one is machined from stainless steel. Pretty cool paddle. I'll hold it up when we're done. I have others. Paddles are neat. It's a very personal choice because that's your the interface between your fingers and the radio. CW is very much a it's a human interactive, like playing a musical instrument kind of activity. So the paddles are really subject to a lot of personal preference. So I don't know if anyone wants to spend any time looking at circuitry. We have double E types who want to see what's inside, and I won't spend too much time on it because unless you're really into it, it's just kind of a bunch of squiggly lines. But I'll go through it because there might be some people who watch the video. So here's some of the circuitry. So the idea is to run this thing on very low power. So whatever you do, you have to choose parts and things like that aren't going to draw much current. So every time I pick a part, I find out, well, how much current does it draw? I know, well, the CMOS ICs, the little logic, they're basically zero. You don't have to worry about those. But I'm going to close the door a second. So, for instance, whenever I have a resistor that's hooked up to the power supply. Here's some resistors. It goes from +5 to ground. Well, if those resistor values are too low, it's going to start drawing a lot of current. And, you know, I mean, you can drain the battery just by putting a resistor across it, right? So you use very high value resistors. That's one of the keys to low power design. And this is thing called a comparator, and its output changes depending on the relative voltage at its inputs. That's how a comparator works. And this one only draws a few microamps. So, you know, very, very low current to operate this thing. So this is a little oscillator, and this is another comparator that changes the duty cycle, the output. We call that weight. A weighting on CW can make your fist sound a little bit different. By default, it's a 50% duty cycle. You know, it's on and off 50% of the time. It usually sounds better if it's on just a little bit more than 50% of the time. So I put a weight knob on my keyer. The fancy electronic ones usually have a way to set it, but you have to like send a command to it. So this clock system draws 27 microamps for the whole thing when it's sitting there at idle. Now the power supply is kind of cool. The way this works is a touch of one of the paddles turns it on. So this is a P MOSFET that's a switch. So I have a 9-volt battery, and this MOSFET is turned on as soon as you pull the gate low. And then it sends 9 volts around actually to the side tone, and then a little low power 5-volt regulator for the logic. There's some that have even, this one draws 100 microamps, well, up to 100 microamps or so. That's just the current drawn by the regulator, which is a lot for a circuit like this. There's others who draw even lower current. And this one has a 555, this is a CMOS 555 that generates a little clock. And then this is a divide by 2 to the 12th little counter. So after about 1800 seconds, that's half an hour, of nothing going on, it generates a pulse to turn the whole thing off. So that way, you know, even though, I mean, the thing draws some current, it draws 210 microamps for the entire keyer. And if that just sat there at idle, it would last about 5,000 hours on a lithium 9-volt, something like that. But with the power off circuit, you know, I'm not here most of the time, so you might as well turn it off. So essentially this battery will easily last its shelf life, probably 10 years or something like that. So I could glue the battery into there and, you know, never have to worry about it. And here's output drivers. So yeah, this is good old, you know, interface logic that a lot of guys learn about eventually. So I like to use a little MOSFET to key the transmitter. The transmitter out here, all it needs is a connection to ground to key it. So you can use a relay, you can use a transistor, whatever. I use a MOSFET because the gate doesn't draw any current. So you drive this thing, it's another, you know, zero current kind of a thing. Now, in the old days, with tube transmitters, they were different because depending how they're keyed, most common was they're called grid block keying. And what you were presented with at the key jack was a high negative voltage. It could be negative 50 volts, maybe 100 volts, something like that. And it's a negative voltage. And this circuit up here with the MOSFET can only handle a positive voltage. So we would do something different, like this would be a high voltage PNP. This would key negative voltage. Or a lot of times use relays. There are going to be problems with relays. Read relays are okay. Sometimes the contacts get stuck and things like that. Guys used to use mercury wetted relays. That was pretty common for keying relays. So that's it. That actually is the end of the show. So what I'm going to do is stop the share, and I can show you a couple things. So here's paddle number 1. So this is my Bengali, and they have adjustments here for the force on the contacts and the contact spacing. So as you actuate the paddle, they hardly move at all. It's a very, very tiny motion, just thousandths of an inch. And the contacts are in the back here with a bearing up in the top of the housing. So it's just like a pivot. So you got you can see the 2 paddles there. So that's a Bengali. I have another one here. This one was custom made for me by an old craftsman in England. I think this is the best paddle in the world. I had it, there we go. Yeah, so this is done in, yeah, it's gold plated. And he gives you different finger pieces. He has some that are made of wood, that are alternates for this thing, but it's still the same idea. And this uses, as the Bengali does, these are magnets right here. There's a magnet on each side. So it uses magnetic repulsion to keep the arms in place. So that's a pretty cool paddle. I like it a lot. It feels good. You go nice and fast, fewer errors and things like that, which is what it's all about. Here's my wind keyer, one I showed before. You can see it's a nice small box. I kind of modified this one a little bit. It's got the buttons for the messages. And I'm going to try something. It's probably not going to work. So I have my wooden keyer here. And in the back, there's a jack there for the paddle, and the RCA jack goes to key the transmitter. So I'm going to plug a paddle into it. And there's a problem with Zoom. I don't know if you know it, but Zoom does a really good job of filtering out noise. So if there's like a continuous tone or something screeching in the background, the Zoom codecs go after that and notch it out. Well, one of the things they're very good at notching out is Morse code. We've seen this over and over again in demonstrations. The guy will be doing something, you'll hear like one dit, then you don't hear anything after that. So see if you hear dits. Okay. So this is the thing I was saying, if you squeeze the paddle, so one side is dashes, there's dits. If I squeeze, okay, pretty cool. And then I'm going to change the weight. I'm going to turn the weight all the way up. I'll turn the speed down a bit. That's high weight. And then you kind of hear the difference, the duty cycle. Yeah, hopefully it didn't, didn't filter out. So here's the low weight. And then here's the high weight. So that's the effect that weighting has. But that's really all there is to it, is just, keyer with a paddle plugged into it. And that really is, the entire system there. Of course, like I said, these days, your keyer is built into the radio. So so it's just kind of your choice then whether your external keyer works better for you or something like that. So that's pretty much the presentation. So I'm here to yak about anything else anybody may have.
So I noticed that the closer you are to the mic with that, then the less filtering, the less notching that Zoom does. So that it seems to be a SPL thing. But yeah, we could hear it drop out when you were a little further away.
Okay. Yeah.
One thing that might be really good to kind of highlight and go through is the different modes, the different iambic modes.
Yeah, the iambic modes. Yeah, those are kind of interesting. The main one, iambic A versus iambic B. You can look it up on the web, and they'll have some descriptions on there, some of which make sense, some that don't. Think of iambic B as having a little longer memory. If I very quickly touch one paddle then the other, iambic B absolutely will send, if you want to call it, the future element. So if I hit, a da, then a dit real quick on the paddle, much faster than it's actually sending, it'll send the da, then it'll send the dit, even though my hand is long gone. Okay, so it's thinking off in the future. So iambic B tends to allow you to kind of send ahead a bit. You can be a little bit ahead of the keyer. If I tried that with iambic A, if I went da dit real fast, I would just get the da. It would miss the dit. So that, in a sense, is the big difference in iambic A and B. And if you're used to one, the other will drive you nuts, to say the least. The other funny ones are called ultimatic. And that old Kodak's keyer I showed was an ultimatic, as it turns out. Ultimatic's kind of fun. So I show the iambic here. You know, I squeeze and I get da 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 da. I can see alternating characters. With ultimatic, what happens is it puts precedence on one paddle or the other. So, for instance, if I have the ultimatic with the da having priority, I can be holding the dit paddle, and as soon as I hit the da paddle, it takes over and I start sending dashes. Even though I'm squeezing, it will just generate dashes. Or you can have it set up where you're squeezing, it just generates dits. Now, why is that good? Well, I have no idea. Well, it turns out my old Kodak's had this da priority, the dash priority. Well, it happened that my call sign had a J in it, which is da da da. So I could actually squeeze. I would start with the dit and just mash on the dash side, and I would get da da da. I would keep sending dashes forever as long as I squeezed. So what it amounts to is those different modes, especially the ultimatic, would give you like a faster or maybe a more efficient or more convenient way to send certain letters, certain numbers. It'll be better for some, worse for others, is what it amounts to. So those are things that you have to practice with, and it's like learning to type on a different keyboard. You know, you really get accustomed to one, and someone changes it up, gives you the other. You'll go nuts. You know, it's like, I cannot send with this thing. It's hilarious. I should also mention there's such a thing as a single lever paddle, and the single lever, you can't squeeze it, so it's dits or das, one or the other, and there's a lot of people that's their preference, that's what they learned with, and they can't do the squeeze keying to save their lives. That's fine. I can do single lever okay. I'm not quite as smooth with it, but it's okay. It's not really hard to go down to single lever. And someone who's used to single lever, if they get an iambic paddle, they just send like a single lever. They just end up moving their fingers back and forth like this and never squeezing, because that doesn't compute with their brains. They're just not, they don't have the muscle memory to do it. But it's a lot of fun.
So one question I have too, that's kind of for everybody, what are your favorite paddles, or what works for everybody else? Just kind of curious what everybody's experience is like.
Let's see. Tony's got a paddle. Does he? No. Does Paul? Paul, you're an old timer. I mean, come on.
My favorite paddle is the one paddle that I have. I got it from MFJ on eBay. Didn't know anything about what I was buying, what I should be buying. And it's sitting there and it works. And so currently it's my favorite.
All right.
But that's why I'm listening to Gary's talk. If you want to trash some of those Bengalis, send them my way, okay?
Right. It's always good to have a spare.
Yeah, that is a spare.
Yeah,
I do have a comment about the zoom and the background noise. When I was taking the CW Ops class not long ago, they made a point. One, you have to turn original sound off. That changes the way it handles background. And in the audio settings, there's a setting for strong background suppression and weak background suppression. So somebody wants to play with those, it may help things. But original sound off, I think, was one of the one of the things we had to do.
Oh, okay. Yeah, I just opened the control panel on the thing, and
Yeah, if you hunt around in there, you'll find some options. So, but
like it has a setting for suppress background noise. By default, it's on what they call auto, and you can also set on basically low, medium, or high.
right, but there's somewhere is another setting called original sound, and actually mine shows up in the upper left corner. I'm not sure why on the main page here, and you can toggle that on and off.
Interesting. Yeah, there's a lot of settings.
That's an exercise for the student. One other comment is, did you consider, instead of a battery, does it make sense to think about putting a capacitor in there? Because batteries leak.
Yeah, the capacitors are worse though.
Oh, okay.
Yeah. Yeah, I worked on supercapacitors back in the 90s, actually, of all things. But yeah, they leak down by themselves. I do use them for backup on certain things, and they last pretty long. I mean, it could be quite a few days on a full charge, but not years. I mean, a lithium battery, you're talking a shelf life that's out 10 years or more, something like that.
How about a little solar panel on top of the unit lit by your light bulb or something?
Yeah, it could be solar powered. It doesn't draw much current at all. So I mean, it would probably be powered by by the room light. That would actually be enough. Yeah, it's really fun. I mean, low power design these days, you can do what they call it, micro power, nano power, whatever. There's ICs that can do almost anything on nothing. It's just astoundingly low power. Yeah, so I've got a nice collection of keys back there, and I could do someday a history of Morse code and sending devices or something like that. But I enjoy sending with a straight key. I got one right here. Actually, this is the one. This is the one I learned Morse code on back in the 1970s. This is technically it's a J37, and I still use it once in a while. When I get below about down about 15 words a minute or so, I switch to straight key. It's just more convenient for me. Takes a little bit of practice, but it's a lot of fun.
So Gary, how often do you send, and what happens if you don't send for a month?
In terms of Rust setting in, I'm on pretty rarely, but I went, let's see, almost 30 years I was off the air. Yeah, almost 30 years. And I got back on, and my CW speed never got below about 20 words a minute or something like that. And I grabbed the paddle for the first time, set it up, and really it was, it didn't take long at all. I mean, it was just, a couple hours noodling around with it, and I was comfortable again. And if I don't, I mean, if I want to go, really, really fast or something like that, then yeah, my proficiency will fall off, and after a month or so, I won't be quite as good. I mean, for conversations, if I just want to send a call sign, it's not a problem. But if I want to, rag chew with somebody for half an hour, then I'd be making more mistakes if I hadn't been on in a month or two.
Yeah, because I found, I took the CW Ops class, took 2 of them. And then I went to Maui for a week, and I took like 3 weeks off, and I was up at like about 12 words per minute. And I came back, and the rust had set in, and I've been struggling to kind of get back my instant character recognition. So it wasn't like falling off a bike. It was like crash and burn.
Mm-hmm.
And I think when you're learning, you really need to stay consistent for a long period of time. That's hard to do.
Yeah, and the learning phase is very important, and especially to not learn bad habits. and hopefully, the instructor coaches you. And, I mean, what you hear, that's fine, but especially on sending, it's the same as, you're learning a musical instrument. Now that's kind of what it is. And a teacher will say, hold your hand like this, make this motion. Why? Because this is most efficient, and you'll find out that in the long term, it's most comfortable and, best suited to, higher speeds, longer, more hours of operation. So people have different styles. For instance, an old timer who learned on a bug. Here, I'll pull out a bug for you. So here's a good old Vibraplex bug. And so this is an electromechanical device, and this works, this armature here vibrates on a spring, and that's how it automatically makes dits. You make the dashes yourself, manually. So the paddle, just like these automated paddles, one side is dashes, and you hit the other way, and it causes this thing to vibrate. Anyway, but to operate this, I mean, you have to put some energy in this thing. I mean, it's a big mechanical system. This is extremely heavy. This weighs, almost 3 pounds. This is cast iron. The base on the thing is cast iron. So people, to operate it, they actually slap the key. I mean, their hand is really, really moving when you operate a bug. Well, what happened is the old timers would learn on a bug, and their arm is, really slamming away. So now you come to a paddle, and you've got this, this delicate little paddle like this, which requires a few grams of force to move literally 3/1000ths of an inch. It's like no force at all. And so to use these, we hold our fingers very close and we make very small motions. Well, the old timers, they're in there, slamming away at the thing. And it's okay, the paddle tolerates it. This thing also weighs about 3 pounds, and it stays put. Well, I'm operating at the contest station, N6O, and the guy next to me, old Mike the Russian, he's an excellent CW operator. And he has his paddle. It would be the same as one you have, Rich. It's actually made by Bencher. His paddle is airborne when he's sending. I mean, it is flying, bouncing off the desk as he's just slamming away at this thing. So that's a rather different sending style, but works for him. That's pretty funny. Anyway, I do enjoy bugs too. So that's yet another universe of sending devices you have to kind of learn to finesse over time. Those do take a lot of practice to send smoothly. And that a bug I get rusty on in relatively short order, and my sending gets really sloppy if I'm not careful with a bug. Rich, I think you're muted.
Can I do a sort of a sales pitch here?
Yeah.
Yes. Okay. Sure. So I took over the LARK Club swap and shop functions from Dave Counts, and I just went through and picked up got a list of everything that we have. So I have a MFJ 401D here, and if anybody wants it, let me know. We're selling things cheap from the swap and shop right now, and so there you go, cheap, no problem.
Right. Morse devices for sale here.
Yeah, I'd love to have some people come through with some keys they're not using. The one nice thing about being in the swap and shop as the coordinator is I get to look at all of this equipment, all of this stuff, and it's really interesting.
And always looking for donations. Well, if I have anything, I'll let you know.
Okay.
Does that mean I get to dump it at your house?
Unfortunately, yes.
Good. I like that.
Think of me as a what are the places where you stick all your excess furniture and everything? Just a storage area.
Yeah, Rich's storage unit. No, it's good. Pretty cool. So what else do you guys need for technical topics? Does anybody have anything else that, I mean, for future? I mean, I'd be glad to do, you know, other things if something comes up. So just let me know.
Propagation is always kind of interesting.
Yeah, that'd be good for a regular meeting.
Yeah, that'd be really interesting, especially differences between VHF, UHF, and HF propagation.
Mm-hmm.
We'll definitely have Jerry. You need to talk to Jerry about that because he's
Yeah.
an activities guy and he can get you set up for a meeting and then do a follow up the following Saturday, a technical where you can dig in deeper into it.
I see. Yeah. Yeah, we're lined up. Ian and I are going to do our W6SRR remote station. I think we're doing that in May. And I had another one lined up. So I can hardly remember. What was it? So let me see here. Just a second. Oh, I have another talk we'll do sometime in the future. I can call it "Am I Getting Out?" And it's about all the techniques you can use to find out how well your transmitter is getting out, as well as how well you're receiving. There's all kinds of automated tools out there to help with that. So that'll be sometime in the future. I'm going to do that one.
So Gary, here's kind of related maybe to that talk, and it's a little bit obtuse, but so how I'd like to measure the power output of an FRS radio, but they got a fixed antenna, so you can't hook it into anything directly to measure it. You know, I've got GMRS radios, and I can just put those through a little box through the antenna port there, because I can take the antenna off. So if you have a way of, and this is low power obviously, of measuring a radio's output handheld without having a connection directly to it, and it could just be relative, you know, relative signal strength. That would be kind of cool. I'm very involved in Neighborhood Radio Watch, which has kind of come out of El Dorado County, and they either use FRS radios or GMRS radios. So I've actually been measuring the power output of my radios to see that they're actually what they say they are, but I can't measure the FRS radio. So if that ties into your talk about how am I getting out, I'd be interested.
Yeah, if you don't have direct connection, it's a little difficult. You know, we don't really have an integrating sphere like we do in optics. You know, I mean, you can certainly measure, you know, proximal field strength. A couple of instruments to do that. When you have a direct connection available, then we normally use a spectrum analyzer, which of course I have a spectrum analyzer. So that also lets you know what the distortion products are like on the transmitter. Like the Baofangs were classically infamous for, you know, violating FCC regulations and all the crap that came out of them. But it does take a spectrum analyzer to check that. I mean, relative field strength is pretty easy to measure with, depending on the band. I have a little power meter that goes up to 450 megahertz, and then the spectrum analyzer goes to 3.6 gigs. You can even put if you build a small dipole carefully crafted, it can actually be used as a field strength meter. But, you know, it's a matter of how far you are from the radio and the polarization of the antenna. So, you know, it's easy to make a relative measurement, but that's about
Yeah, I'm thinking that if I had, say I had a GMRS radio and I can program that and put it down on the FRS channels, which they're supposed to be able to do, and, you know, get a, you know, like a little field strength meter and say, okay, it's putting out half a watt, and then take, you know, their omnidirectional antennas and then take the FRS radio and just broadcast and see if I get the same signal strength.
Yep. Yeah, you do it at just put it at exactly the same distance. I just happen to have a field strength meter. It goes from 50 megahertz to 8 gigahertz. They're cheap. They're $100. It just tells you that just integrated field strength. So yeah, you turn the thing on and just set it, like exactly 1 meter from your reference antenna and stuff like that. So that's a simple way to do something like that.
Might give that a try. Thank you.
Yeah. It's available for borrowing. I might never use it. You can also check your microwave for leakage.